He got the whole world in his hands. 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 Good. Indeed, Jesus has the whole world in his hands. You also have the whole world in your hands. That is why you are on this platform with me, so that we can continue with our studies by imparting knowledge and sharing ideas. Good. I am in the person of Otu Michael, and today I am your facilitator, and I'll be taking you through mathematics, still on the topic set and its operations. And our subtopic for today is how to represent set of numbers on a Venn diagram. But before we move on with today's lesson, let's share a word of prayer. Father, we thank you for promotion. We thank you for knowledge. We thank you for wisdom. We thank you for understanding. Be our teacher in today's lesson. In Jesus' mighty name that we pray with thanksgiving. Amen. Alright. Now, let's go through the objectives. Objective 1. At the end of the lesson, a student should be able to list elements of set of numbers and their subsets. Objective 2. We should be able to come up with the intersection and union of set of numbers. 3. We should be able to find the complement of set of numbers. And lastly, we should be able to represent set of numbers on a Venn diagram using the intersection and complement of set of numbers. Alright, now before we proceed to the next slides, I want to throw more light on subset and number of subsets. Good. Now, if we have set U equals into curly bracket 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we are saying that if set A equals into curly bracket even numbers. Alright, now if A becomes a subset of U, that means we can list the elements of A, because we said that the definition of a set is objects of the same kind, object with a common property. That becomes a set. So set A says even numbers. Now if A becomes a subset of set U, then we can list the elements of set A. So A will give us 2, 4, 6, 8, 10. Why? Because we understand even numbers. When we say even numbers, they are numbers that are divisible by 2. As we saw it in our previous lesson, we came out with the differences between odd numbers and even numbers. We said odd numbers are numbers that are indivisible by 2, but even numbers are numbers that are divisible by 2. So if A becomes a subset of U, that means that all the elements that are for set A must come from set U. Now let's talk about number of subsets. if I have set B equals into curly brackets 1, 2, then we can say that the number of elements of set B becomes the cardinality of a set. And when we say cardinality of a set, we are talking about the number of elements of a set. So we can say that here set B is having 2 members. So the number of subsets of set B is given by the expression 2 raised to the power n. Now our n denotes the number of elements of the set. So we are saying that set B will have 4 subsets. Alright. Good. Now we have activities over here. Let me take you through these activities. It says list the elements of the following sets of numbers and their subsets. We are to list the elements of these sets and their subsets. Set A equals into curly brackets the first 3 letters in the English alphabet. Set B equals into curly brackets minus 2 less or equal to x less or equal to 3. Set C equals into curly bracket factors of 2. Good. Now let's take the first question. We said set A is the first 3 letters in the English alphabet. So our set A will give us A equals into curly brackets A, B, C. These are the elements of set A. Now let's look at the number of subsets of set A. We said that the number of subsets is given by the expression 2 raised to the power n. Now our n denotes the number of elements in set A. So we can say that n equals to what? 3. That means that 2 raised to the power 3 will give us 8. Because 2 raised to the power 3 means 2 times 2 times 2. And that will give us what? 8. Good. Now let's look at set B. We said that set B is minus 2 less or equal to x less or equal to 3. That is for set B. Now because of the notation under the bar under the notation sign, we have to start from -2 and end at +3. So the elements for set B will start from -2, -1, 0, 1, 2, and then 3. Good. So we are saying that the number of elements in set B is given by 2 raised to the power n. So our n will give us 1, 2, 3, 4, 5, 6. So n will give us 6. Hence, the number of subsets of set B will be denoted by 2 raised to the power 6. And 2 raised to the power 6 will give us 64. Alright, now let's continue. Now, the last set, set C. We are saying set C is factors of what? 2. So factors of 2, that is set C. We are going to have 1 and 2. That becomes factors of 2. So our number of subsets of set C, because set C is having 2 members, we are saying that n equals to 2, and the number of subsets is denoted by 2 raised to the power what? 2. And 2 raised to the power 2 will give us what? 4. That means that the number of subsets of set C will be 4. Alright. Now Now let's move on. Good. We have intersection of sets. When we say intersection of sets, how do you understand intersection of sets? We are saying that in mathematics, the intersection of two sets A and B, denoted by A intersection B. See, that is the symbol to denote intersection of elements of sets. Is the set containing all elements of A and that of elements of set B. Now, for example, if I have A equals into curly brackets 1, 2, 3, 4, and set B equals into curly brackets 2, 4, 6, 8, then A intersection B will give us elements found in both sets. That becomes intersection of set, element found in both sets. Now let's look at set A. We have 1, 2, 3, 4. Then set B, we have 2, 4, 6, 8. So A intersection B, we want to come out with elements found in both sets. That is, elements that are common in set A as well as what? Set B. So we have 2 and 4. These are the elements common to both sets. Alright. Now, we are saying that the set operation intersection takes only the elements that are in both sets, as you saw it in the example that we just did. Alright, now we are throwing more light on intersection of sets. We are saying that the intersection contains the elements that the two sets have in common. So if you look at the example that I displayed earlier on, we got 2 and 4. That means that 2 and 4 are found in both sets. Alright, now let's look at the activities. We have set U equals into curly brackets 7, 8, 9, 10, 11, 12, 13. Then we have set A equals into curly bracket 8, 10, 12. Then we have set B into curly bracket 10, 12, 13, and set C we have into curly bracket 7, 12, and 8. Now we are to find A intersection B intersection C. That is 1. 2, we are to find A intersection B. Then 3, we are to find C B intersection C. Alright. Now, this one tells you that set A, set B, and set C, they are subsets of set U. Alright. Good. Now, let's look at something over here. We are to find A intersection B intersection C. We want to come out with elements found in all these sets. The elements that are common to both sets. As we saw it earlier on, we came out with set A, set B, and set C. So you can see that the common member found in both sets is 12. Good. That becomes A intersection B intersection C. I hope you are also jotting something down, and I hope you are following the activities that we are going through. Now, I also have A intersection B. Good. Elements found in A and at the same time found in B. Element found in A and at the same time found in B. So you can see that set A is made up of 8, 10 and 12. Then set B, we have 10, 12, 13. So elements, common member found in set A and at the same time in set B are 10 and 12. Alright. I hope you are getting your answers right. Now let's move on to the last question. We have to find B intersection C. So we are comparing set B and set C. We said that in set B we have 10, 12, 13, and set C we have 7, 12 and 8. So common member found in these two sets is 12. Wow, I hope you were able to come out with the correct answers. Now let's move on. Now we are done with the intersection of sets. We are saying that when we talk about intersection of sets, they are the elements found in both sets. Elements found in both sets. That becomes intersection of sets. Now let's look at union of sets. Union of sets. If intersection of sets becomes element found in both sets, then union of a set, we are saying that in the set theory, the union, which is denoted by the symbol U, of a collection of sets is the set of all elements in the collection. I repeat again. When we say union of a set, we are saying that the union of a collection of sets is the set of all elements in the collection. Let's try to throw more light on this. We are saying that the union of a set is found by putting two or more sets together to form one set. We are still throwing more light. We are saying that the union of two sets is a set containing all the elements that are in set A or in set B, possibly both. Elements found in both sets, we put them together. So an example, we have a set as in 1, 2, union 2, 3. So the union of these two sets is found by putting the two sets together as in 1, 2, 3. So we combine the two sets. Explanation. We can write X as in A union B. That means that all elements of X belongs to set A and what? Set B. We are saying that if X belongs to A union B, then X should come from A and it should come from where? Set B. So we are saying that A union B should be equal to B union A. That becomes commutative property. So all right, now let's look at example over here. I have set X equals into curly brackets M N O P. Then I have set Y equals into curly brackets K U and then Z. Now X union Y, what I have to do is to put these two elements together to form a set. So I'll start with M, N, O, P, K, U, Z. The union of two sets is found by putting the two sets together. So that becomes A union B. Also, if I have A equals into curly bracket 5, 6, and B equals into curly bracket 1, 2. If I want to find A union B, what I have to do is to start from the smallest number. So I'll start from 1, 2, 5, 6. I have gotten A union B. A union B. I just put the two sets together to get another set. Alright, let's move on to complement of a set. Now, when we say complement of a set, we are saying that the set of all elements in the given universal set that are not in set A. That is, if A becomes a subset of set U. I repeat, the complement of a set, which is denoted by A inverse, is the set of all elements in the given universal sets that are not in set A becomes a complement. So an example, we are saying that U complement equals to an empty set, which is a null set. So we are saying that the complement of an empty set is the universal set. Let's try to throw more light on what I have explained. For example, if set U equals into curly brackets all natural numbers from 1 to 10. If A is a subset of U and A equals to into curly brackets even numbers, we have to find a complement. Alright, so what we have to do is to list the elements of what? Set U. So set U will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set A will give us 2, 4, 6, 8, 10. Because we said even numbers and we understand even numbers already. Now A complement. A complement becomes elements that are in set U but cannot be found in set A. I repeat, when we say A complement, they are the elements found in set U but cannot be found in the subset. So the subset of set U is A, and the elements of set A are even numbers, as you see it on the screen. So elements that are in set U and cannot be found in set A becomes A complement. It's just like subtraction. So the element of A complement will give us 1, 3, 5, 7, and 9. These are elements that cannot be found in set A. So elements that cannot be found in set A and can be found in set U becomes A complements. Good. Wow. Representing set of numbers on a Venn diagram using intersection and complement of sets. Let's see what we have. Activity 1. Activity 1. What do we have over here? We are saying that given that P equals to prime numbers, you know prime numbers already, less than 10, and Q equals to odd numbers less than 5. We have to find A intersection B and show A intersection B on a Venn diagram. Prime numbers. What are prime numbers? When we say prime numbers, we are saying that these are numbers that has only 2 factors. A prime number is a number with only 2 factors, the number itself and 1. So 2 becomes a prime number, 3 becomes a prime number, 5 also becomes a prime number. It has only 2 factors. When we say odd numbers, these are numbers that are indivisible by 2. That means that when you divide 2 by any of these numbers, there should be a remainder. That is an odd number. A property has been defined over here. So we have to list prime numbers that are less than 10. Prime numbers less than 10. Good. Let's see. So asset P will give us, we said prime numbers are numbers that has only 2 factors. So we have 2, we have 3, we have 5, 7. Now we are saying that these numbers should be less than 10. So 2, 3, 5, 7. These numbers are less than 10. They are prime numbers too because they have only 2 factors. Now let's look at set Q. We are to list odd numbers. Odd numbers less than 5. 1 becomes an odd number, 3 becomes an odd number. So these numbers are less than 5. Alright. Now we have to find P intersection Q. Now earlier on we explained that when we say intersection of numbers, they are the element found in both sets. Intersection of numbers becomes element found in both sets. So if you look at set P, we have 2, 3, 5, 7. Then if we take set Q, we have 1 and 3. So elements found in both sets, we will have only 3. And this one defines a unit set. So a P intersection Q will give us a unit set. When we say unit set, we explained earlier on that unit sets are sets with only one member. Alright, now we are to represent P and Q on a Venn diagram. We will also throw more light on Venn diagram in our next meeting. But how do we represent P and Q on a Venn diagram? So we come out with our diagram like this, with our 2 circles, and we come out with the place where they intersect. So we have set P, then we have set Q. Now we are saying that element found in both sets becomes the intersection of sets. So as you can see it on the screen, 3 becomes the element found in both sets. That means that if you look at the Venn diagram, it is made up of 4 regions. We have region 1, region 2, region 3, region 4. Now, the region 1, 2, the region 2 becomes the intersection of P and Q. So we will put our 3 here. Now, because 3 is taken out, we can find P only. elements that will be left after taking the 3, we will have 2, 5, and 7. That means that 2, 5, and 7 will be written in region 1. So we have 2, 3, and 7. Now let's look at K-O. So we want this one is P only, and that is K-O only. So Q only, if 3 is taken out, the element that will be left is 1. So Q only will give us 1. So we will put our 1 there. That is how to represent set of numbers using intersection on a Venn diagram. We said that first we need to come out with our intersection of sets, and the intersection of the set gave us a unit set because we got only one member found in both sets. After that, we need to come out with our Venn diagram. Now we drew the Venn diagram as you see it on the screen over there. Then we have to come out with the place where the two sets meet, and that is what you see it over here. That is the place where the two sets meet. That is P intersection Q in the blue color, the green color. So we have P only, we have Q only. The reason why 3 is not here is supposed to be 5. Alright, so 3 is not placed over here is because 3 is found in both sets. Good. Now let's move on. Activity 2. How do we solve this question also? M and N are subsets of the universal set U such that U equals into curly bracket natural numbers less than 13. M equals into curly bracket numbers between 1 and 13. And N equals into curly bracket multiples of 4 between 9 and 13. We have to list the elements of U, M, and N. At the end of the day, we have to show this on a Venn diagram. Let's try to come out with the answer to this question. So our U will give us, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't forget, we said that it should be less than 13. Now our M will give us 2, 4, 6, 8, 10, 12. Then our N will give us 12. Alright. Now, before we can represent this on a Venn diagram, let's try to find M intersection N. I hope up to now you know the intersection of sets. So our M intersection N will give us element found in both sets. So the element that can be found in M and at the same time N is 12. So we put it in the curly bracket. Now we need to get M only. So M only will give us, since 12 is taken out, we will be left with 2, 4, 6, 8, 10. Alright. Now let's draw our Venn diagram and see what is left. Alright, good. So we have M, we have N, we have U. The intersection gave us 12. Good. Now in region 1 explains M only. So M only, these are the elements we are going to see over there. Because 12 is taken out of M, elements that will be left are 2, 4, 6, 8, 10. As for N, nothing was left. Now, the element that cannot be found in both sets becomes M intersection N, or complements. So let's look at the element that cannot be found in both sets. We have 1, we have 3, we have 5, we have 7, we have 9 and 11. These elements are always placed outside the two circles in the Venn diagram. So 1, 3, 5, 7, 9, 11 becomes the complement of set A and set becomes the complement of set N and set M. Good. Wow. What do we have over there? Assignments. Students, I want you to go through this assignment and then try your hands on it. Is that okay? So that when we meet again, we will be able to come out with the answers. Now, I have a quote for you, and this quote is from John Wooden. It says, he said, "Don't let what you cannot do interfere with what you can do." All that it means is that as students, we shouldn't let what we cannot do affect what we can do and do it better. What can we do better in this generation of ours? We have to take our studies very serious. We shouldn't allow the worldly things define our studies for us. We shouldn't conform to the worldly things. We should always be transformed by the renewing of our mind, so that we can prevent ourselves with the things that cannot promote us. Take your studies very serious. And until I come your way next time, is bye-bye for now.